Hi, and welcome to Quick Add Math on straight line graphs. Here are some prerequisites to begin with. Given 2 points on a linear graph, x1, y1, and x2, y2, the distance between the 2 points is the difference in its x square plus the difference in its y square, all being square root, per the Pythagoras theorem. Its midpoint is the average of its x value and the average of its y value. Last but not least, the gradient of the line is the ratio of the difference of its y against the difference of its x. Do note that the order in performing the difference matters. More prerequisites. Given two lines, namely one with a gradient of m1 and another with a gradient of m2. When the two lines are parallel, m1 must equal to m2. And when the two lines are perpendicular, the product of m1 and m2 equals -1. Tutorial question 1. The distance between 2 points 6 and -2 and 2a is 5. Find the two possible values of a. In this case, the difference in its x value square plus the difference between its y value square, all square root, must equal to 5. By inserting these numbers into the equation, we could then solve for a as being 1 and 3. Tutorial question 2. A parallelogram ABCD has its A at -76, B at -18, and C at 73. Find the coordinates of D using the midpoint formula. For this question, the center of the parallelogram is the midpoint of AC. By working out the averages of its x and y values, the midpoint of AC is 0, 4.5. Now let D be equals to xy. By using the midpoint formula, we could calculate x as being equal to 1, also y being equal to 1, and hence getting to D being the coordinate 1, 1. Tutorial question 3. A trapezium ABCD has its A at -1, -5, B at 5, -2, and C at 1, 1. Additionally, its AB is perpendicular to AD, and its AB is parallel to DC. Find the coordinates of D. I wish to start by letting the coordinates of D being xy, the gradient of AB being m1, the gradient of AD being m2, and the gradient of DC being m3. Given that AB is perpendicular with AD, the product of m1 and m2 must equal to -1. By inserting the respective coordinates into the equation, we could set up the first simultaneous equation of 2x plus y being equal to -7. In the question, it also mentions that AB is parallel to DC. This allows us to position m1 being equal to m3, and inserting the values of the coordinates into the formula, it allows us to set up equation 2, which is x minus 2y equal to -1. By using the elimination method for simultaneous equations, we could then solve y as being equal to -1, which allows us to get x as being -3. Therefore, the coordinates of D is -3, -1. As for the equation of a straight line, we should be familiar with y equals mx plus c. There is another way of expressing the equation of a straight line. This is y minus y1 being equal to the product of m and x minus x1. On this slide, I put up the general formula of how one could calculate the area of a polygon from the coordinates of its vertices. Tutorial question 4. find the equation of the line in perpendicular with 4x minus y equals 6 and passing through the point 4 minus 1. By rearranging the given equation, we have y equals 4x minus 6, which has its m at 4. Knowing that the product of gradients for two perpendicular lines being minus 1, the perpendicular line will have a gradient of minus 1 over 4. With the perpendicular line also passing through the point 4 minus 1, we could use the formula of y minus y1 being equal to m times x minus x1 to get to our required equation. Next, I want to talk about how we can convert a non-linear equation to linear form. As an example, y equals ax squared plus b is a non-linear equation. However, if we were to plot a graph with its vertical axis as y and its horizontal axis as x squared, the graph will appear linear. This is in a way saying that for the equation capital Y equals m capital X plus c, we would have its capital Y being equal to y of the first equation and the capital X being equal to x squared of the first equation, with m now being equal to its a and c being equal to its b. Note that m and c must only be expressed in terms of the constants, which is a and b. Tutorial question 5. State the variables capital X and capital Y and the constants m and c with the conversion of y equals ax plus b over x into the form capital Y equals m capital X plus c. In this case, you take the equation and multiply x to both sides of the equation. With this, the variables capital X is x squared, capital Y is xy, and the constants m is a and its c being b. Tutorial question 6. State the variables capital X and capital Y and the constants m and c with the conversion of x to the power of a, y to the power of b being equal to e to the power of 2 into the form capital Y equals m capital X plus c. In this case, you apply log to both sides of the equation and use the laws of logarithm to get to the required equation, with the variable x being the log of x and the variable y being the log of y, with its constants m being equal to minus a over b and the constant c being equal to 2 over b. Tutorial question 7. Express y in terms of x for the relationship on the graph. This is the reverse of what we done in tutorial question 5 and 6. In terms of capital Y equals m capital X plus c, from the graph, the capital Y is equal to x plus y, and the capital X is equal to x squared. Also from the graph, we could calculate its gradient from its 2 points, allowing us to state that capital Y is now equal to 1.25 capital X plus c. By placing one of the coordinates into this equation, we could then identify c. With this, we could write the complete equation and expand it in accordance such that you would have it represented purely as a y in the form of its x. That's all for straight line graphs. If you found this beneficial, be on the lookout for other videos under the KT tutorial channel.